Hello students, so we are doing application of derivatives and exercise 6.1. Some questions we are solving. So question number 11. Okay, a particle moves along the curve is given 6y equal to x square plus 2. Find the points on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. Okay, now the second sentence is what? The y coordinate is changing, so it is changing 8 times as fast as the x coordinate. Okay, so you have to convert that sentence. Okay, now you have to find the derivative of this. That is, this is your equation is given of curve. Okay, so with respect to t we are derivating, so this will be x dy by dt equal to 3x, okay, 2x, it is cube. Okay, so this is 3x square and the derivative of x with respect to t. Okay, now this 3 you can take here, so this will be 2, so 2 times dy by dt x square dx by dt. Now you have to make use of this equation. Okay, so you have to substitute this equation in here. So 2 times dy by dt is given 8 dx by dt x square dx by dt. Okay, so this will be 16 dx by dt minus x square dx by dt equal to 0. Okay, so you can take common dx by dt, so 16 minus x square dx by dt is equal to 0. So either this is 16 minus x square is equal to 0 or dx by dt is equal to 0. Okay, so this will be 4 minus x and 4 plus x, right? 4 square minus 4, this is a square minus b square, so 4 minus x, 4 plus x equal to 0. So x is either plus 4 or it is minus 4. Okay, so you have two cases, that is x equal to plus 4 and x equal to minus 4. So when you substitute it in y, that is this equation which is given, okay, you will get two values of x. So let's substitute x equal to 4 plus 4 so 6y equal to 4 cube plus 2, this will be 64, so 6y equal to 64 plus 2, so this is 66 by 6, so it comes to 11. Okay, then we have x equal to minus 4, 6y minus 4 cube, so it comes with a negative sign, minus 64. Okay, so this will be minus 62 upon 6. Okay, so this will be minus 31 by 3. Okay, so when when x is equal to 4, you will get 11, and when x is equal to minus 4, you will get minus 31 by 3. So these are the points on the curve. Okay, question number 12. So radius of an air bubble is increasing at the rate of half centimeter per second. At what rate is the volume of the bubble increasing when the radius is 1 centimeter? Now bubble means the sphere, right? Just like this. So its volume is 4/3 pi r cube. Okay. Now it is given that radius is increasing with the rate half centimeter per second. At what rate is the volume increasing when the radius is 1? Radius is given 1. Okay, you have to find the rate at which the volume is changing. So take dv by dt. So d by dt of 4/3 pi r cube. So 4/3 pi, you have to derivate with respect to r and with respect to t. So this will be 3r square into dr by dt. Since dr by dt is given half, you have to substitute it here. So half. So this will be 2. So 2 pi r square. And also the radius is given. So dv by dt at r equal to 1 you have to find. So this will be 2 pi. Okay. It is a volume. So centimeter cube per second. Okay. Question number 13. A balloon which always remains spherical has a variable diameter 3/2 into 2x plus 1. Find the rate of change of its volume with respect to x. Okay. So a spherical balloon is given and has a variable diameter. So dia is 3/2 2x plus 1. We need radius. So you have to take half of the diameter. So 3/2 into 2, that is we are taking the half, right? So this is 3/4 2x plus 1. Now you have to find the rate of change of its volume with respect to x, not with respect to t. Okay, so dv by dx you have to find. So its volume is 4/3 pi r cube, right? So r, in place of r you have to substitute this value. So this will be 3/4 2x plus 1 cube. Okay, so 4/3 pi you can take outside also. 3/4 the whole cube you can take outside. We have to derivate 2x plus 1 the whole cube. Okay, so this will be one of the 3 goes, of the 4 goes. So this will be 9/16 pi. Derivative of this will be 3 times 2x plus 1 raised to square, and then the derivative of 2x, which is 2. Okay, so you can cut this to 8. So this will be 27/8 pi (2x plus 1 the whole square). Okay, this is the volume with respect to x. Okay. Question number 14. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. How fast is the height of the sand cone increasing when the height is 4 centimeter? Now this sand is falling, okay, on the ground, so it will form a cone. Okay. Now the sentence is height of the cone is 1/6 the radius of the cone. Okay, this you have to use. Now how fast is the sand cone increasing when the height is 4 centimeter? Now this is sand cone is increasing means this is filling up, so you have to find the volume. They have asked for the volume. Okay, and the height increasing when the height is 4 centimeter. Now sand is pouring from a pipe at the rate of 12 centimeter cube per second. See, 12 centimeter cube means this is a volume which is given. Okay, so volume of the cone is given to be 12 centimeter cube per second. Okay, also at this height you have to find the how fast height is increasing when the height is 4 cm. Okay, now so this is not volume, this is changing volume with respect to time. Okay, so take the derivative of volume of the cone is 1/3 pi r square h, that is 1/3 of the cylinder, right? Now you have to substitute here this r we don't want, because we have to find how fast the height is changing. Okay, so you have to find the dh by dt. So you don't want r here, so in place of r you have to substitute h. So r will be 6 into h, right? So substitute 6 into h the whole square into h here. Okay, so this will be h cube, and this is 6 into 6, right? So 3, so it is 12 pi, and then you have to take the derivative of h cube, so it is 3h square, and then with respect to t. Okay, that is a chain rule. So now this will be 36 pi h square dh by dt. dv by dt is given, that is 12. Okay, you can substitute it here. Now take this 36 here, so this will be 1/3. Okay, also h is given 4, so you can substitute here, so this will be 16. Okay, that 16 you can take here again, so 3 into 16. Okay, so this will be dh by dt 1/48 pi. So your height is changing with respect to t, that is increasing. Okay, since it is positive, and height is a length, so centimeter per second. Okay, so this is a question. Find the rate of change of area of a circular disc with respect to circumference when r is 4 centimeter. Now they have asked to find rate of change of area with respect to its circumference. Okay, what is area of a circle? Pi r square. What is circumference? Circumference is the boundary. Okay, that is 2 pi r. Okay. Now to find this, r is given, okay, 4 centimeters. So you have to bring r in this. So you have to take this is with respect to r. Okay, area changing with respect to r, and circumference changing with respect to r. So dA, so d by dr of pi r square, and d by dr of circumference. So this will be 2 pi r, and this will be 2 pi, right? So it comes to be r. So dA by area changing with respect to circumference at r equal to 4, you will get 4, okay, area is centimeter square upon second, okay, per second, and your circumference is centimeter per second. So this will be only centimeter, okay, because second gets cancelled, one of the centimeter also gets cancelled. So this is the answer, okay.